In the previous video, I presented Laravel Reverb with MQTT and ESP in action. And in the Internet of Things cloud that we are going to build, I will of course use various type of development boards or microcontrollers. Depending on the model, it might be necessary to use different technique in the connection process. In today's video, I will working with the Arduino Nano RP2040 and I will connect to establish a secure connection to an MQTT broker using TLS encryption. We'll be using the Wi-Fi Nina library along with Wi-Fi SSL client to connect to a HiveMQ broker. Let's dive right into the code and see how it is done. I start in the Arduino IDE. I set up for the Arduino Nano RP2040, and the first step I will create a header for the secrets, credential, password for Wi-Fi. For example, I go here, new tab, and I will write, for example, secrets dot, and here I will insert the authentication for the Wi-Fi, define. Now I go back in the main file, and here the first step I will add I will include the library and some variables. For example, I need the Wi-Fi Nina, include Wi-Fi Nina dot hash. Also, we have Wi-Fi Nina for handling Wi-Fi connection, Wi-Fi SSL client for secure SSL TLS connection, and pub sub client for MQTT communication, and of course the secret with the credential. Now, next step, we have some variables for Wi-Fi and MQTT credential. Here the Wi-Fi credential, secret SSID and secret pass are stored in this separate header file, and MQTT server details are also can include in this file, but for this example I have here. Next step, we initialize a client object. For example, Wi-Fi SSL client, SSL client, and we need the pub sub client, and of course this SSL client. Wi-Fi SSL client is used for secure connection over SSL TLS, and we pass this client into the PubSub client, which manage our MQTT communication. This function is responsible for connecting Arduino Nano RP2040 to the Wi-Fi network, and that is standard stuff, and we print some status message to the serial monitor to keep track of the connection status. Next step, we define a callback function for incoming MQTT messages. This simple callback prints the topics of any received MQTT message, which is useful for debugging or basic message handling. And then this function reconnect attempts to connect to the MQTT broker if the connection is lost. It also subscribes to the topic I write here RP2040 connect input, and if we subscribe here, we go the message in the serial monitor. Now in the setup function, we init the serial connection and call our setup Wi-Fi. The setup Wi-Fi we define here, and here we call. And next step, we can define in the loop function to manage the MQTT connection and send messages. For example, like this. This is a simple light version. This loop checks if the client is connected, and if not, it attempts to reconnect using our reconnect function. Reconnect function that we define here, and if there are any message available from the serial monitor, they are read and published to the MQTT broker on the topic RP2040 connect output, and that's it. Now we can make a test, and we have a problem here. Compilation error, use serial was not declared in this scope. Yeah, we must define this. For example, here define use serial, and we check, and now it looks good. Now I connect in the HiveMQ client with all topics, and I see in serial monitor I am connected to the Wi-Fi and I am connected to the MQTT broker. Now I can send a message, super test, and I see the topic and the message is here, and it works.